Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss limits and derivatives. In this chapter, we are going to discuss the problems in the exercise 13.2, page number 313. 313 in the textbook. In the previous class, we have discussed the concepts of the exercise 13.2 as well as we have completed 9 questions so far in this exercise. I hope you have learnt well. I hope you understood well. Haven't you, my dear children? Right. Now come to the question number 10. Find the derivative of cos x from the first principle. Understood this question, my dear children? The first question in this exercise, we have found the derivatives of the given functions from the first principle. So here you have to bring back that knowledge. What is that knowledge? Derivative of a function from the first principle. You have to bring back this knowledge into your mind. F dash of x is equal to, as h tends to 0, limit of f of x plus h minus f of x by h. This is called derivative of the given function f of x from the first principle. Okay, my children. Without knowing this definition, you can't find the derivative of the cos x from the first principle. Okay, my children. Right. Now let us assume that f of x is equal to cos x. Okay, my children. Let us consider the given function is f of x. F of x is equal to cos x. Then f of x plus h, because f of x plus h term is there, f of x term is also there. So to substitute these values, we are finding the values separately. F of x plus h, cos of x plus h. In the place of x, we have to write x plus h. Understood this step, my children? Right. Therefore, derivative of cos x, therefore derivative of cos x from the first principle is equal to, it is denoted by f dash of x is equal to, as h tends to 0, limit. In this formula, let us substitute these two values. Okay, my children. Cos of x plus h minus cos x by h. Here f of x plus h is there in the numerator, that is the first term. What is f of x plus h? Cos of x plus h. So we wrote cos of x plus h minus, what is the second term in the numerator? F of x. What is f of x here? Cos x. Okay, my children, understood this numerator, whole divided by h. Okay, my children. So we have to find the limit of this function as h is approaching to 0. If you apply direct substitution method, we get 0 by 0, that is indeterminate form. But we should not get a indeterminate form for limit of a function. Okay, my dear children. So we have to follow some other method. For that, we have to use the trigonometric transformation formula. We assume that this is cos C minus this is cos D. Cos C minus cos D formula. In the numerator, we use cos C minus cos D. What is the formula? Minus 2 cos C minus cos D minus 2 sin C plus D by 2. C plus D by 2 into sin C minus D by 2, x plus h minus x by 2 whole divided by h. In the numerator, we used this formula cos C minus cos D is equal to minus 2 sine C plus D by 2 into cos into sine C minus D by 2 into sine C minus D by 2. This is called transformation formula. In the trigonometric chapter, you have learnt this transformation formula. Cos C minus cos D is equal to minus 2 sine C plus D by 2 into sine C minus D by 2, where C is equal to x plus h and D is equal to x. So we are substituting these two values in this formula, then we get this numerator. Understood this part, my children? Right. I wrote here the previous step again. That implies f dash of x is equal to, as h tends to 0, limit of minus 2 into sine of x plus h plus x by 2 into sine of x plus h minus x by 2 whole divided by h. Okay, my children, this is nothing but a previous step. Okay, my children, now let us simplify. Here, minus 2 is a numerical coefficient. We can write it outside. So, minus 2 into, as h tends to 0, limit of sine of x plus x. What do you get? 2x plus h by 2. Okay, my children. Right. Into, here, plus x minus x gets cancelled. As h tends to 0, limit sine h by 2 whole divided by h. I am writing this whole divided by h below this number. Below this number we can write it, because there are two factors. We can write this denominator below the any one of these two factors. Okay, my children? Right. This is equal to, here we can direct the substitution. We can use a direct substitution. For finding the limit of this function, we can use a direct substitution. So sine of 2x plus 0 by 2. For finding the limit of this function, I used here direct substitution. Okay, my children, into, here it is in the form of, as x tends to 0, limit sine ax by x. So what is the coefficient of h here? 1 by 2. So we can write 1 by 2. The limit of that function is 1 by 2 only, because as x tends to 0, limit sine px by x or sine ax by x is equal to a. I gave the list of standard limits. In that limit, standard limits, this is also there. As x tends to 0, limit of sine ax by x is equal to a. So here x is equal to h. Okay, my dear children. A is equal to 1 by 2. Understood this formula, my dear children? We are using this formula to find the limit of this function. So 1 by 2. Whatever the coefficient of x is there, that is the limit of that function. So what is the coefficient of h? 1 by 2. So limit of this function is 1 by 2. Okay, my children, understood this one? Right. Here 2 gets cancelled. So minus sine of 2x by 2. Okay, my children, understood this step? 2 gets cancelled. Minus sine x. This is a derivative of cos x. Therefore, f dash of x is equal to minus sin x. Therefore, derivative of cos x is equal to minus sin x. In the list of standard derivatives, d by dx of cos x is equal to minus sin x. Isn't it or not, my children? d by dx of cos x is equal to minus sin x. This is also standard derivative. Okay, my children, understood? Right. Now come to the question number 11. In this question number 11, total 8 parts are there. Total 8 parts are there. Out of these 8 parts, here this is the first part of this question 11. Find the derivative of cos x into sin x. Understood this question, my children? We had find the derivative of sin x into cos x. Okay. Now come to the solution part. Let us assume that f of x is equal to sin x into cos x. The given function is considered as f of x. Therefore, f of x is equal to sin x into cos x. Okay, my dear children, understood this step. Now, let us find the derivative of this function by using UV rule. Let us assume that this is u and this is v. UV rule, product rule. Okay, my dear children, you have to bring back the product rule into your mind. Okay, my dear children. So, differentiating with respect to x. This implies what is the differential operator? D by dx. D by dx of f of x is equal to d by dx of sin x into cos x. This is u and this is v. Okay, my dear children. I wrote here differential operator, that is d by dx on both sides. Understood this step, my dear children? Right. How do you write d by dx of f of x? F dash of x. This can be written as f dash of x. This notation and this notation denote the same. Okay, my dear children? Right. Now we are using here in RHS UV rule. That is also called UV rule or product rule, where u is equal to sin x and v is equal to cos x. What is UV rule? U into d by dx of v. So sin x into d by dx of cos x plus v into cos x into d by dx of sin x. Okay, my dear children, I am writing here formula d by dx of uv is equal to u into d by dx of v plus v into d by dx of u. By using this product rule, this is also called simply UV rule or product rule. We are using product rule or UV rule to find the derivative of this function, because here this function is a product of two factors. Cos x sin x is one factor, cos x is another factor. So you should use product rule to find the derivative of this function. Okay, my children, that is why we are using here UV rule, where u is equal to sin x and v is equal to cos x. Understood this step, my children? Right. This is equal to sin x into, what is the derivative of cos x? D by dx of cos x means derivative of cos x. In the previous question we have found it, minus sin x. Okay, my children. Or in the standard derivatives, in the list of standard derivatives, we know d by dx of cos x is equal to minus sin x. Once you go through that formula, once you go through the standard derivatives, okay, my children, into cos x into d by dx of sin x, what will you get to? Cos x. Because d by dx of cos x is equal to minus sin x, and d by dx of sin x is equal to cos x. By using these two standard derivatives, d by dx of cos x means derivative of cos x is minus sin x, d by dx of sin x means derivative of sin x is cos x. So we wrote these two for two values by using these two formulae, by using these two standard derivatives. Okay, my children, understood this step? So derivatives part is over, differentiation part is over. Now let us simplify the terms. What will you get here? Sin x into minus sin x. What will you get? Minus sin square x. Okay, my children. Cos x into cos x. What will you get? Cos square x. So cos square x minus sin square x. What is the formula? Cos square x minus sin square x. Yes, cos 2x. Because cos 2a is equal to cos square a minus sin square a. Multiple angle formula. This is called multiple angle formula. You have learnt this multiple angle formula in the trigonometric functions chapter. Haven't you, my dear children? So by using this multiple angle formula, we wrote this step where a is equal to x. Understood this step, my dear children? Right. Now come to the second part of this question 11. Question number 11, second part. Okay, my children, find the derivative of secant x. Actually, we know the standard derivatives. In that list of standard derivatives, we know d by dx of secant x is equal to secant x into tan x. Okay, my children, do you remember that formula? Yes, it is a standard derivative. D by dx of secant x is equal to secant x into tan x. But we have to find the derivative of this secant x. Okay, my children. Right. We can use derivative of a function from the first principle or some other method. You can use any other method to find the derivative of this secant x. Okay, my children. So first come to the solution part. Let us assume that f of x is equal to secant x. We are assuming that given function is f of x. Secant x is equal to, how can you write 1 by cos x? Can we write it or not, my dear children? Secant x can be written as 1 by cos x or not? Yes or no? Yes, we can write it as 1 by cos x. Now, it is in the form of u by v. U by v. So, we use u by v formula. That is quotient rule. To find the derivative of this function, we use the quotient rule. Got this idea, my dear children? Yes. So, differentiating. So, therefore, f of x is equal to 1 by cos x. So, it is in the form of u by v, where u is equal to 1 and v is equal to cos x. Okay, my dear children? So, differentiating with respect to x. What is the differential operator? We are differentiating these functions with respect to x. Then what is the differential operator? Yes, you should remember differential operator also, my dear children. So d by dx of f of x is equal to d by dx of 1 by cos x. In this step, I wrote differential operator d by dx on both sides. Okay, my children, understood this step? Right. How do you write d by dx of f of x? Yes, this can be written as f dash of x. Okay, my children, that is nothing but derivative of f of x. This also denote derivative of f of x. Okay, my children, now come to RHS. D by dx of 1 by cos x. Previously, I told you it is in the form of u by v, where u is equal to 1 and v is equal to cos x. What is the d by dx of u by v? V into, that is cos x into d by dx of v means u means 1 minus 1 into d by dx of cos x whole divided by cos x whole square. Okay, my children, understood this step? I write here u by v rule, d by dx of u by v is equal to v into d by dx of u minus u into d by dx of v whole divided by v square, where u is equal to 1 and v is equal to cos x. So in this formula, I substituted u and v values. Then we got this step. Understood this step, my children? Right. This implies f dash of x is equal to, come to the first term in the numerator, cos x into, what is the derivative of 1? 0, because it is a constant function. derivative of a constant function, there is no variable. Derivative of a constant function is 0. Derivative of a constant is 0. Okay, my children, understood this 0, right? Minus 1 into, what is the derivative of cos x? Yes, minus sin x. Okay, my children, understood this minus sin x, right? Whole divided by cos square x. This can be written as cos x whole square, can be written as cos square x. Okay, my children, because d by dx of constant is equal to 0 and d by dx of cos x is equal to minus sin x. We used these two standard derivatives. We used these two derivative formulas to write the numerator part. Understood this step, my children? Right. So derivative differentiation part is over. Now let us simplify the terms. Okay, my children, that is equal to, in the numerator, what you get? First term 0, because cos x into 0, 0. 0 minus of minus, what you get? Plus sin x by cos square x. Okay, my children, understood this step? Right. So sin x by this cos x can be written as cos x into cos x. Can we write it or not? Cos square x, can we written cos x into cos x or not, my children? Yes or no? Yes. So now come to this part. Sin x by cos x. What is the sin x by cos x? Tan x. Isn't it or not, my children? 1 by cos x, secant x. Tan x into secant x. That is equal to secant x into tan x. Okay, my children, therefore, d by dx of secant x is equal to secant x into tan x. This is a standard derivative. This is also formula. Okay, my children, understood? Derivative of secant x is equal to secant x into tan x. Okay, my children. Here I am not explaining the remaining parts in this question number 11. Please try the remaining parts in this question number 11. Will you try the remaining questions in this question number 11, my children? Yourself. Try yourself. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children? Right. To, to find the derivatives of the remaining functions in this question number 11, please go to the list of standard derivatives. Use the list of standard derivatives and find the derivatives of the functions given in the question number 11. Okay, my children? Right.